Is light a particle or a wave? Let's see. To understand this, we will need to know what is meant by particle and wave. First, let's look at particles. Particles are like a solid object. That means like a ball or any other solid object that you may encounter in your daily life. So they are solid, they can't be broken down any further or made up by other materials or substance. So that is how we think about particles. They are objects that cannot be broken down further by other substance or made up by other materials. So they are the smallest of matter, the individual constitutes of matter. That is what a particle is. And what about a wave? A wave, you can think of this as a chain of particles that are connecting to each other like this, keep connecting. And if you just think of they are just connecting particles, and what if you just apply a force to one of the particles? Then this particle will go up and the other nearby particles will follow it, since they are all connected together like this. So if you move only one particle, the other particles will follow its movement. And if you recognize this shape, this is kind of a part of the wave. And if you extend this chain of particles, what you will get is like a wave, like a vibrating wave. That means if a wave is vibrating, that means you will move the particle up like this, then go down like this. If you just draw the particle when they are below, so they are all connecting to each other. And you see, this is also like a wave, only the next moment of the wave. So you can think of a wave as a vibrating string of particles. And all the particles on this string are all connected to one another. So that is what a wave is, or how it should be think about. So if a wave is just a chain of particles, and do you think light is a particle or a chain of particles that is wave? And There are experiments done in the last century by many different scientists, and the most significant of them all is the double slit experiment, and the setup is like this. There are two slits that are apart from each other, and you send a light, you flash a light on to the two slits, and behind those two slits are a wall or a projection screen that projects the light on that screen. And what do you think will happen if you shine a light between those two slits? And here is what happened. If you draw the intensity of the light like this is the intensity of light. You can see the middle has the highest peak. That means its intensity is the highest, and others around it has lower peak. That means the intensity are lower. And what do this result show? Let's consider both cases. That means if you think a particle is a light is a particle, what will happen is when the particle is passing through those slits, whatever direction the particle is traveling when it is passing through those two slits, it will extending towards the screen. And that you can see all the direction that the particle travels on the side of the screen. If there is only one light source, and if there is only one light source, then there should be two separate strip of light, and in the middle are blocked by the middle slit, so no light can pass through. So only two strips are observed if light is a particle. But what we observe is not like this. Is the intensity of light is highest when it is in the middle. So what happened? If you think of light as a particle, that means if you think of light as a wave, not a particle, so when light as a wave is traveling towards the two slits, Then at those lists, there are two separate waves that is traveling towards the screen. And if you see what this pattern is, you may recognize this. This is the interference pattern, and the line curve that is drawing. If you extend those intersections, you can see the light will intersect constructively interfere with each other in the middle. Since those are the intersection points, and they will also have some other constructively interference position, but they are less intensive. So this is the shape, the intensity if the light is a wave, and this shape matches what the experiment is observed. So this experiment implies that if light is a wave, it should produce this pattern, this interference pattern that we observed. And this experiment proved that light is behaving like a wave. So light is not like a particle, but a wave. But do you think that that's it? That means light is a wave, not a particle. And you will be surprised when you do the experiment again. But this time, let's listen out. But this time, you will add a device that measures or detects which slit the light passes through. So a device is going to detect which slit the light is passing through, and if you add that device and do the double slit experiment again, and let's draw this. So imagine from the double slit experiment, you conclude that the light is a wave as before, and it will produce the interference pattern you saw. So this should be what you are expecting, an interference pattern. But since this time we do the same experiment with an added measuring device that detects where the light is passing through. That means you detect which slit the light has passed through, and the experiment result is not the interference pattern again. So instead, what is showing on the screen, not the interference pattern. So this part is not, but what you are seeing on the screen are those two strips of light. So when you think you did an experiment that prove light is a wave, and you do that experiment again, but this time you detect which slit the light is passing through, and you expect to see an interference pattern, but instead what you see is the two strips of light, and those two strips of light can only result from if you consider light as a particle. That means light is a particle from a source towards those two strips. So those two strips are light particles. And we didn't change anything except for a measuring device that detect which slit the light is passing through. Other than that, the double slit experiment stays the same. And why do you think this will happen? And there is an very unintuitive answer to these two phenomena. And the answer to these two phenomena, that means light can behave like a wave, like here, and can also behave like a particle when it is measured, is described by a theory called quantum mechanics. And that theory explains why light will behave like in this way. And the way that the theory explains it is the light is a wave when it is not measured by any measuring device. That means you cannot extract any information from that light. But when you try to extract some information about the light by measuring it through some measuring device, then the light will turn into a particle. But the exact way that how this is happening is not well understood, as like measuring device just collapse the wave into a particle, and that is the mystery of quantum mechanics. that is still not well understood by scientists today, and that could may that may be explained, may be solved by other theory, like something called string theory or other theories are trying to explain this phenomenon and trying to understand how this process is happening. And the theory is too complicated to explain for now, since the dimension of space needs to be extended, and we can hardly think of any extra dimension other than the three dimensions we live in. So it will be not explained now, and since it is very hard to grasp by the someone that listening that may not have background in this theory, and that is how the theory of light from the double slit experiment that was done to look, make light behave like a wave, to put a measuring device to measure which slit the light will pass through, and it no longer show the interference pattern. And to now, the scientists are developing theories to explain this phenomenon, and this is a great topic to dive into if you want to figure out what is the true nature of light. And I may encourage someone who is listening on this to look something about the experiment, or think why this phenomenon could happen, because there is still not an exact explanation to why this is happening. So if you can think of a way why this phenomenon happen, then we may be able to understand this phenomenon better and solve the mystery of the nature of light. And we may finally know that light may not be a particle nor a wave, but something that that exhibits both properties of the particles and wave. And what could that be? That's up to the scientists, and maybe one of you that are listening that may become a scientist in the future to figure it out.